Hello everyone, and welcome to pCloudy's webinar on root cause analysis for mobile app performance issues. My name is Dinakar, and I'll be the host for today. Before we get started, I would like to go over a few housekeeping rules. You may have noticed that your line is currently muted. If you do have any questions during the webinar, you can use the Q&A option and submit your questions during the webinar there, and we'll get to those answers. We'll get to the answers at the end of the webinar, or if we're able to, we'll do it while we're doing the presentation itself. Please note that this webinar is being recorded, and we will send out the link of the recording to share with your colleagues later. With that said, let me introduce the speaker for today, Jessica Selvin. Jessica is a pre-sales specialist at pCloudy. She has around 4 years of experience in the IT industry. Prior to her role at pCloudy, she has worked with giants like LTI Mindtree as a pre-sales consultant in automation solution design, and for various other industries as well. She has a keen expertise in data analytics and various automation tools. So without further ado, let me hand it to our speaker, Jessica Selvin. Over to you.
Thank you so much, Dinakar, for that introduction. So I hope my screen is visible and I'm audible.
Absolutely.
Yeah, great. So as Dinakar mentioned, our topic for today is doing a root cause analysis for the various performance issues that you would encounter while testing your mobile application, right? And how would we go about doing that? And what are the road obstacles that are typically faced by QA teams when going about handling performance issues in mobile applications, right? So that would be the focus of our discussion today. And we will be wrapping up with a live demo as well. Firstly, and to what you might relate to even on a day-to-day basis as you use mobile applications, right? You will be able to see that here are some stats before you, right? So studies show that 65% of users lose trust after just 2 app crashes. So this is huge because trust is very hard to regain, and a stable app in today's world is not just a technical goal; it is a business priority, right? So, and even as a personal user of many applications, you might have faced when you encounter issues like this, it does cause you to lose trust and abandon the application. Right. Next is the page load time. The other stat is that for every second of page load delay, can reduce conversion rates by roughly around 7%. And this is particularly, impactful in e-commerce, banking sectors, which might lead to direct revenue loss, right? So a fast loading app encourages higher user conversion rates for your application. And thirdly, you can also see 7 out of 10 users prefer app sizes less than 50 MB, right? So especially in markets where data and storage are constraints, keeping the app size in check ensures that you have a smoother first-time experience and does not, strain the device. So this is another key factor. So I'm just listing out some key factors. As a user, you might be able to relate to this as well, right? And the app launch time. So there is a higher bounce rate and app abandonment rate when the app takes more than 5 seconds to launch, right? So this would lead to the user retention coming down. And finally, on the scroll performance as well, it is critical for user engagement and for users to be retained on your application. So even incremental improvement in scroll performance can yield a 3% increase in user engagement, right? So small optimizations can lead to significant benefits over time, which will directly lead to a good business impact, right? So this is so no longer, as I mentioned, no longer is a stable app something just to a technical achievement. It is a business priority, right? So with that context, let's just see a further deep dive into what are the customer expectations of today, right? With the complex digital infrastructure that we have, your app will have multiple layers. So be it the UI layer in which your user base is accessing the application, be it from mobile phones, tablets, right? And the middle layer where the app thinks and talks to other services, right? So for example, managing security and authentication, firewall, and integrating with other services. And finally, at the bottom and the backend layer, we have the databases, the internal and external APIs, and the core systems of your and architecture of your application, right? So with this complex digital infrastructure of your application, the customer expectation still remains high, right? With as here are some popular examples, right? They expect it to be as seamless as Instagram and as fast as Google, smooth and secure like Amazon and Apple, right? So this is the type of expectation that users have for their any application that they're using, and they're comparing it to these applications. And they're looking for a flawless functional experience, right? A lag-free performance experience, right? So as well as 24/7 availability. So ensuring that every feature works reliably each time. And as we had already mentioned, right, even seconds of delay can cost in your conversion rates. And finally, a perfect visual experience where all your animations are rendering smoothly, the page transitions are smooth, and so on. So these aren't, again, features anymore, they're expectations, and becomes part of your user base's expectation, right? And your app becomes your brand. So the users would be equating the quality of your app experience with the quality of your brand itself, right? So that is the kind of expectation that's there. So with this expectation and user experience that we see of user experience, why do app performance issues keep coming up? Right, this is something, and especially coming up in the later stages, post-production even, right? So firstly is the lack of identifying real bugs. So symptomatic treatments, or only seeing surface level issues and unable to identify what are the real bugs, right? Not enough testing coverage. So limited test coverage, be it in different scenarios, or be it testing on different devices, OS versions, different location, network conditions, right? Being able to provide real world context and being able to test in different scenarios. So this is also something that is challenging. Next is access to meaningful data, right? So there is a lot of fragmentation, multiple sources of information, right, which is fragmented, maybe spread across multiple teams even, right? So this makes it difficult. And the type of data that you get, it's also difficult to infer and get insights from that data. And it's hard to get those precise metrics, like be it your response times, your CPU, memory, that's also aligned with actual user behavior, right? So this is a core issue, not having access to meaningful data, not having a single source of truth for your information, and not it being fragmented across different teams, making it difficult to collaborate. So this forms one of the core issues as to why this keeps coming up. And finally, a single performance bug can cause cascading failures, right? Like the domino effect, making root cause identification even more harder. So QA teams would be finding it difficult to trace errors precisely across the app's architecture and struggle to pinpoint exactly where it started and how it started impacting other areas. So this is another issue that is faced. Now, let's just take a step back and see what is the ideal way to do defect management, right? And how is it supposed to be done with this context? So firstly, it is finding and documenting the bugs, right? Defect identification, grouping and categorizing your defects, and as well as prioritizing, making it easy for teams to understand what to fix first. And then developers get into fixing the issues based on the priority and ensuring that they need to get it to the root cause and not just the symptom, ensuring that this issue is not a recurring issue. Then QA validates and verifies this, testing to confirm that it resolves the issue and it doesn't introduce other new bugs, right? And the issue is closed and it's retested across different scenarios, and ensuring that the coverage is high and ensuring that app is stable across different environments and devices. So this is the ideal way in which defect management should be done. But what are the kind of realities that we see with defect analysis, right? Firstly, we see a band-aid approach, right? So be it though the process looks seamless, the reality is very different, and there's a lot of challenges, right? Defect fixes end up being quick patches rather than long-term solutions, and teams are focusing on making the error disappear or the symptom disappear without addressing the root cause. And yeah, like I said, fixing the symptoms, the deeper problem often goes undetected, leading to bugs resurfacing later on, causing further delays. And again, key to the issue is not enough data, like I mentioned, not having actionable insights, not having data that actually reveals the why behind the issue, right? Without meaningful metrics, you can only guess where things are going wrong without actually being able to do a proper RCA. Inability to replicate errors, right? So this makes it harder to validate and to fix this. And teams continuously being stuck more in the reactive mode, issues being found in the production, right? And only when a certain symptom is found, then reacting to that and doing a symptomatic solution to those issues, right? So this is the reality that we see in defect analysis. And with that, what are the cost of defects that we see? And especially in what stage of your software development lifecycle do you see these issues coming up? And what is the cost in the different stages, right? So the earlier you detect and fix your bugs, the cheaper it is going to be, right? So for example, at the requirement and design stage, it is the least impactful in terms of your cost, in the cost impact, and it would be nearly negligible. And the cost would increase as you move forward. Being the highest in the production, right? Once it's your application is deployed, the cost, both in terms of your brand reputation as well as financially, the identifying performance-based issues post-production would be really high cost to you, right? So it is imperative to really prioritize doing performance, not just functional validations, but performance validations for your application before it is you have deployed your application, right? And not just in the context of load testing, but at the app level, at the user level, to see how is it actually for an individual user to use your application, and what are the backend metrics that might be causing the user experience to be impacted. So that as well is critical, right? So the focus should become more and more shifting the testing left, or shift left testing, making sure that we detect the performance issues, address the performance issues as early as possible when it's easiest and as well as cheapest to fix. So yeah, this is a humorous way of actually illustrating what is the problem when you symptomatically treat something, right? So be it in any personal life situation, as well as what we see in QA, right? With root cause analysis, ensuring that you're actually focusing on the cause and not just the symptom or the effect, right? So and this is and having a structured way to find out why a problem happened. And RCA is a mindset shift, right? And the goal should be to prevent the recurrence. So ensuring that you start with the symptom, yes, you start with the apparent problem, but you get to the deeper root causes, have the possible root causes, and then you finalize on the actual root cause and deliver a solution that ensures that it doesn't repeat again in the upcoming versions of your build, right? So that should be the goal and the mindset shift when it comes to root cause analysis. A few other challenges that come along with mobile app performance and what makes it tricky is, firstly, device fragmentation, right? You need to ensure that you test across different devices. You might have seen your app work on one particular device in one version. What is the ensuring that it's covered across different versions and different builds and different scenarios, right? So be it your device type, screen sizes, OS versions, hardware specifications. So it becomes challenging to test reliably across the entire mobile ecosystem. Next, varying network bandwidth, or for example, in different network conditions. So the app may work well in a strong network, but may degrade sharply, right, when the connectivity is lagging or limited. Next, complex user journeys, right? So modern mobile applications have highly dynamic user flows, right, with different steps and longer critical user journeys, right? So testing every path to spot those bottlenecks is also critical, but challenging. And finally, tool fragmentation. So to get the data, QA teams are using fragmented tools for different test scenarios, be it for performance and another for functional testing and another for analytics. So this will lead to delay, inconsistencies in result, different teams not collaborating, right, and not having enough data to make a correlated decision, and will affect the data interpretation. So these are some of the things that will make mobile app performance tricky in particular, right? So how can we resolve this, and how has pCloudy strategized this solution, right? So that's where we're getting into the solution part. And pCloudy has been forefront of these kind of trends and innovating, particularly in the AI app testing space, right? So to accelerate growth and to be innovative in terms of the strategy, particularly in the mobile app performance space. So firstly, the solution is to measure the right app performance indicators, all right, ensuring that you have your CPU data, your memory, and all these different metrics. So I have just listed out a few here, but there are 60 plus metrics that pCloudy's app performance dashboard will give you, right, ensuring that it is presented in such a way that is shareable, that can be easily correlated, right, and it's easily understandable, right, and it does not require multiple sources of truth, right? So that is something that is really important in ensuring that you have the right data and a right framework within which you're looking at it. Implementing a solid test reporting strategy, ensuring having a quick overview of the data, having easy to understand reports from a single source, having detailed logs, and ensuring that the reports are easily shareable. Also having access to the UI side, like be it the corresponding screenshots, and also being able to easily correlate the screenshot with the metrics, access to the video, and integration with other bug tracking tools. So these are just some of the key points that you need to have in mind while having a solid test reporting strategy, particularly on the performance side. Next, how pCloudy is flipping the script with performance experience testing, right? So be it, So we are tracking, as I mentioned, 60 plus metrics, and we're monitoring everything from your CPU, your battery, to your UI metrics, to your network data, right, across platforms, having real-time data collection. So we have a real device data infrastructure, so that makes it much easier to get the real-time data and capturing as they happen without any synthetic delays or sampling errors, right? So ensuring that you have real-time data collection and advanced data processing. So we have AI working behind the scenes in order to categorize the data to give you AI ML-based insights based on the metrics collected. So let's just see on a high level the different layers of the solution. The first and foremost at the bottom you see is our diverse real device infrastructure. So we have 5,000 plus device browser combinations, and particularly on the mobile side, we have hundreds of real devices that are hosted in our data centers. So these are real devices, not simulators or emulators. These are physical devices hosted in our data center. So this ensures that you can create and run your performance test as authentically, right, in a real world testing scenario. and testing across. So we support all the latest versions, right, both on Android and iOS for you to test on across different OEMs like Apple, Google, Samsung, right, and several others. So you will have a real, true, diverse coverage for you to do your performance runs. And secondly, you have the performance data collection engine that will go through the flow of your application. So at the user side, you will simply be doing a critical user journey, for example. But on the backend, there will be all these different data points being tracked, and it will be real-time data collection, right? And thirdly, you have the visualization engine, where you will be, it will take all these metrics and plot them into charts and graphs that are easily understandable to the user. And finally, we have ML-based categorization, anomaly detection, right, that will give analyze those metrics and give you the analysis, ML-based analysis of the same. Right, so these are the layers of how our app performance testing module works. And with that, we will get into the live demo. Just give me a second to share my screen on that. Yeah. So this is pCloudy, our platform, right, where, as I mentioned, we are a digital experience testing platform. And our focus for today is the app performance module. But other than that, we support functional testing, automation testing, integrating your frameworks with our devices, both on our devices, mobile devices, as well as browsers. We also have an AI agent, QPilot. But our focus for today is our app performance. So let's just get straight to the app performance module. So this is the device list that we have, right? These are the real devices that I was mentioning that are hosted across in our data centers. You can connect to any one and begin your app performance testing. So prior to that, we first need to ensure that our application, our APA or APK or IPA file is uploaded into the My Data section. So this is where you will be uploading your builds to do your testing, right? So you will simply need to click on Upload File and upload your application into the My Data section here. And for performance testing, there is one additional step that needs to be done, where, for example, you select the application that you want to do your performance run. And under Actions, you click on App Performance Testing. And what this will do is it will instrument your application to make it ready for it to record and collect all those different data metrics, right? So here you can see that I've already instrumented the application. It has added the relevant libraries in order to collect the data. And it has renamed the application as _performance instrumenter. And you can see you will be using this application in order to test, right? So with that, let's just get back to our app performance module. So once we've done that, we're ready to begin our testing. So I'm going to go ahead and select a device of my choice. And it's fetching all the applications from the data section that we have just now uploaded. So I'm just selecting this particular application to do my testing, and I'm going to click on Connect. So firstly, the device session is getting established. And with pCloudy, as soon as you click on Connect, you will have complete access of the device with you. And there is no session limit as such. You will be able to go ahead and do your testing unlimited, right? So here it's asking for creating a tag. That is in case if you want to compare sessions. For now, we will skip that. And also you can see here that the launch times are getting measured. So before we begin our recording of the metrics, the app is going to get launched 3 times to ensure that it's measuring the cold, warm, and hot launch time. So you will be able to see this in the report, and we can see the metrics, measure the metrics there. So once it has launched 3 times, so it will take around 30 to 50 seconds. Once it has launched those 3 times, the recording button is now enabled, as you can see. and I can begin my recording. So this is just a sample application where I'm demoing on, right? And we can begin the recording. So right now, I just don't need to bother about the data at this point. I am just going to go ahead and do any critical user journey, right? So you don't need to worry about what's going on behind the scenes. Just simulate or mimic user behavior. So that is the focus at this stage during your test. So I'm just going to do a very small, simple flow here. So right now, while I'm just mimicking the user journey behind the scenes, the data collection engine that I was talking about, right, that layer is working and collecting all the data behind the scenes. So I'm just going to add an item to the cart. We'll maybe add another item to the cart and be done with our flow. So yeah, I'm just doing a short flow in the interest of time, but there is no session limit as such. You can go about doing your entire critical user journey, a long flow, whatever is required, and go ahead and release the device. So I have now released the device. So we can now get into the reports section here, where we'll be able to see the reports that have been generated. So you can see here, this is the report that's generated. Let's get to it. Yeah. So this is the app performance report that has now been generated, right? So firstly, we are in the summary page where you can see that the app deck score has been generated for this. So you can see that it has given several different categories from poor, fair, good to excellent. And this is a value between 0 to 1, right? And this is basically a metric to measure the response times of your application. So if the response time is smooth and seamless, it will be towards 1. So you can see that this is a pretty high good score, and it's coming under the excellent category. This is measured mainly between the response times of your APIs, between how many are within the threshold and how many are slow. And based on averaging them out, it has come up with this AppDex score. Below, you can also see the AI-based insights that are generated. So it has detected a slow web page load at one point. Right, it has also identified janky frames. So these are frames that fail to render smoothly, right? And it crosses the threshold allocated to it. So that's typically if it crosses more than 16 milliseconds, right? So here it has captured 785 frames that are janky. It has also identified that there are some failed API requests and unoptimized resources. So it has summarized these particular issues, 2 from the UI category and a couple from the network category. And above, you can see all the device-related information. So you can see that the device name, the specifications of the device, right, as well as the session-related information with the timestamp and the duration of the session. You can also see the application-related details like the package name, the version, what was the build number, and the app size. You can also see the app-related insights, right? So for example, the installed app size, what is the maximum or the peak CPU usage, right, that is consumed during the session, averaging out what is the memory usage of the app during the session, and the average CPU usage. And this is what I was referring to with the different launch times, right? So a cold launch occurs when your app is started for the first time after you reboot your device, right? And it's not in the memory. So the first launch, it has happened pretty fast in less than a second. And the warm launch is when it is still in memory, but the activity has been destroyed. And hot launch is when it is typically the fastest type. When it's occurring, it's simply brought from the background to the foreground. So that is on the different app launch times. You can also see the UI related insights over here, like the jank frames, the average frames per second, which will give an idea of the smoothness of your application as well as the stability of your application. You can also see the total number of API requests and what is the error rate of your APIs and what is the average response time of your APIs along with the peak response time, right? So the peak almost took 3 seconds to respond. So these are the kind of insights, high-level overview that you will first get by scanning our summary section of our app performance report. With that, we can go ahead and deep dive into the other sections as well. So firstly, let's get into the app insights section. So let's get there. Yeah. So this is our app insights, which will give you a time series metrics of 20 plus metrics represented graphically across the duration of your session. So you can see, you can scroll through the entire duration of the session, along with giving you what is happening correspondingly in the UI, right? And I can scroll this time series to get to the particular timestamp that I want to analyze, and I'll be able to correlate the different metrics here, right? So you can see here that, for example, at 1 minute, at this particular timestamp, their application CPU is at around 4%. But if I drag it out maybe a little more here, this side, I can see that there is one janky frame that's detected, right? Along with high memory consumption of 66 MB in the Java heap and 184 MB in the native heap, right? So I can scroll around and see that this was during the search for a particular item to add to the cart, right? So you'll also be able to correlate the UI and all the different metrics. You can see that we provide the total frames along with how many frames were janky. So at this point, there were 71 frames you can see. And correspondingly, there were 6 frames that were janky and the others were smooth. You can see the smoothness percentage along with what is the count of frames that missed the deadline. You can also see the GPU, the total memory usage along with the Java native code heap, right? And you can also see the latency count. What is the count of the slow UI thread? As well as, you'll be able to see the transmitted on the network side, right? So you'll be able to see the transmitted packets, the transmitted bytes, received data as well. And finally, on the battery drain, voltage, and temperature. So all these different metrics, 20 plus metrics, are presented graphically for you to analyze along with the corresponding UI. So this is a key differentiator with pCloudy, right? No other cloud service provider or cloud infra testing platform is giving this level of detail into the performance metrics and giving you this level of analysis details, right? So typically you would have to get this type of data, you would have to go to different data sources and have multiple tools in order to analyze it. So here we are giving it to you in a single page, and from our end, we have simply just mimicked a user journey, right? So there is no other technical expertise as such required in order to use the tool. Next is our UI insights. So here you'll be able to see the page transition time between every single page, how much time it took to transition. And again, you'll be able to see the corresponding UI, what is happening, right? And if there is a particular slow load, it is able to detect that and it is marking it as a slow load as well, right? And you'll be able to see it along with the corresponding video, right? So here you'll be able to detect each and every page transition. And finally, this is the Jank analysis, where you'll be able to see the total number of frames and all the frames represented in a timeline. So you can see how many were on time, how many were delayed, and how many might have caused went beyond a certain threshold, which might lead to a lag experience to the user, right? And if there is any dropped frame, that will also be denoted. So you can hover over any particular janky frame and you'll be able to see what is the type of jank, right? And at which layer. So this was at the product main activity. So this is when the product search was going on, right? So you'll be able to share all these details with your relevant stakeholder teams, right? And as I mentioned, these reports are completely shareable. So this link is shareable across to different team members, and they can also go ahead and access these reports. You can also see what is the maximum type of errors in the Jank analysis, along with the count and the percentage of the errors as well. And finally, on the app activity visualization, you will be able to see how many total screens were changed, right, along with the activity name. So you can see there's a pop-up activity, there's a home activity, the cart, searching for the products, and all these different activities, right, along with the performance. So you can see based on the legend here that all these were fast, and this was in the normal range, along with the performance insights, right? So you can see here what was the activity that had the highest load time, what were the activities that were repeated, and what is the overall flow of the application where it's going through multiple screens, 8 screens, and returning to the main activity. So this is the activity visualization page. And next, very importantly, is our network data, right? So this is another key feature and a key differentiator where we are providing the details of all the API calls that were made during your session, right, along with the analysis. So firstly, you'll be able to see the status and the count of your the APIs with different statuses, right? So you'll be able to see the status distribution and breakdown, as well as the timing distribution and breakdown, right? So this is something you'll be able to see. And then you'll be able to see each and every API call that was made. And on the left-hand side are the categorization issues, right? So it has categorized, it has analyzed each and every API and categorized it into different issues. So you'll be able to see what are the failed requests, right? So you can see there's a failed request over here. You can go ahead and click on the slowest endpoint, and you'll be able to click on each and every API. So for example, you can see this nearly took 3 seconds. You can also click on every individual API and see the response body and the timing breakdown and at which stage was most of the time consumed, right? Similarly, you can see if any images were loading in an unoptimized format, which might lead to any performance issues. You can also see APIs that are missing cache headers, right? So cache headers is basically, it will ensure that that particular data is cached and it doesn't have to send the API request again, right? So, and similarly, if there are no cache directives as well for the same reasons to ensure that the API requests are not getting repeated unnecessarily. So you'll also be able to see what are the cache directives that were missing. You can also see if there's any images and static images that are not cached as well. And finally, you'll be able to see what were the repeated API calls. So here you can see that this particular API call was called 7 times, right, along with the count and the details timestamp of those APIs. So this particular API was called 36 times. So this is relevant data where it can be shared with the developers and the relevant teams to see whether these API calls can be optimized, right? So these kind of things have a direct performance impact on the user, right? So looking for opportunities to optimize, right, and having the root cause presented to you directly in this format really helps to make your defect management process much more faster. So this is on the repeated API calls. And finally, you'll also be able to see the domain sharding or the domain distribution. So you can see here that the total requests is 823 with 59 unique domains. And you'll also be able to see what are the distributions of these domains, right? So you can see that primarily and majorly 66% of the API requests were sent to this particular domain. And you'll be able to do that analysis as well. So this is on the network analysis, right? So you'll be able to drill down into each and every individual API and also see the header information. So that is also something that you can share with the development teams, right? So you'll be able to see the header information, preview, the response, and the timing breakdown of your API. And finally, we have the log analysis. So firstly, it will provide you the device logs for you to download and view. And secondly, we have our log analyzer engine that will categorize, go through the entire logs and categorize it into different issues. So you'll be able to see, you can, for example, here it has identified an issue, see that relevant log lines along with it. So you don't need to go through, many lines, several lines of log and analyze it, right? So here the AI categorizes it into different issues. So even if there's any crash, if there's any ANR or app not responding issues, you will be able to see those relevant log lines as well that are categorized here. So this is just to give you a brief on our app performance. This is the kind of data that you'll be able to see. This is the kind of correlations you'll be able to do with our app performance engine, right? And finally, there is one more thing that I wanted to touch upon, which is our compare feature. So you can also compare between two reports. So for example, here, say you have done two different sessions. So in this case, it was on the same device, but two different versions of the build are compared to see if there's any performance difference between the application. So you can see here that the launch times are double from session A. So the second version took a little longer to load. So the first one was 1 second and the second one took around 2.5 seconds. And similarly here as well, it has doubled. You can also see that it has around 13% more issues that have been identified. Like the response time is slightly higher, and as well as the CPU consumption is more higher in session B. So these are the kind of data that you'll be able to compare between two sessions as well, right? So for example, if you want to compare between different specification devices, right? One on a higher end and one on a lower end device, you'll be able to do that and see if there is any performance impact for your application. So for example, you can see the battery drain is slightly higher in session B compared to session A. Right, and similarly on the janky frames, there are a high number of janky frames detected in session B over session A. So this is the type of analysis. You'll also be able to do comparative analysis between two sessions as well. And you can also see the application information. So you can see that the app size is much higher between the two devices, which are two applications, which could have contributed to some of the performance issues. Along with, you can see that the devices were same. So you can see that the comparison was done between two different builds of the application. You can also have the video timeline. So you'll be able to see the video of the entire two sessions and compare them side by side. So that is on our comparative analysis. So hope this gives you a good and a broad idea on the kind of analysis you will be able to do and achieve. What are the kind of root causes you will be able to easily uncover with our app performance engine, and hope this session was insightful. So with that, we will hand it over to the Q&A session, and let's take it from there. So yeah, are there any questions, Dinakar? Are you able to see any questions?
Just a few ones. I can see some on
Sure.
too.
Yeah.
Are you able to see them, or shall I read them out? Or
Just yeah, it would be helpful if you could maybe read them out. Or yeah, yeah, I think I can see them now.
Okay, great.
Yeah. So how can I identify and quantify performance regressions between builds, right? So yeah, this is where your two things would come into place. Another thing that I missed to mention is that we support automation as well, right? So I had manually done a flow, but say, for example, you want to run a performance test from your application, sorry, your automation scripts, right? So you can, for example, if you have an APM script, you can go ahead and run it and enable a particular capability called app performance true. Right, we can share you the documentation on that if you're interested. And you can simply run your automation scripts on pCloudy devices, and you'll be able to do the comparative analysis. So there is no need to manually access in order to do a performance run. So that is, in that way, you'll be able to do it easily compare between builds. Right? Is there a benchmark for app performance? Yes, and we have documentation on this as well. So you can see that for example, for a janky frame, it's whether it's beyond, if it crosses 16 milliseconds, that is the benchmark, right? And for that, there are several industry standards and thresholds. We have detailed documentation on that. We'll be happy to share that with you as well. How can we manage variations in device models, OS versions, and network types? So yes, so as I mentioned, you can choose the devices of your choice, right, to compare between different devices in order to see how the performance is changing. And because pCloudy has real device infrastructure, this will really help in test coverage and ensuring that your test coverage is across different devices, and see whether there's any performance impact for those devices. Next, does it support for iOS? Yes, I have shown this for an Android application for this webinar, but we support the same, and it will be pretty much the same way for iOS as well. There are just a few metrics because of the limitation on iOS side that you won't be able to test it. But yes, typically you will be able to do the exact same performance run for iOS-based applications as well. Can we test the app in different network bandwidths like 3G, 4G, and 5G? Yes, we are providing network simulation where you'll be able to simulate this. Yes. So I think I'm not able to see any further questions. I think most of the questions were covered. If there are any that I've missed, Dinakar, please let me know.
Just a quick one, I think that's come in.
Yeah. Okay. Okay, as a user, how much time I need to use, like 20 or 30 minutes application to collect and give realistic data? So more than time, I would say it is based on the journey, right? Like to perform a critical user journey, like for example, right from onboarding a user, for example, or adding several items to the cart and removing that and getting to the payment page. Right, like these kind of, it's more so of the ensuring that you do a complete workflow that will give you a good idea, right? So there is no session limit, like be it whether it's a 5-minute session or a 30-minute session, the metrics, pCloudy will give you all the relevant metrics, but it's more important that you do a realistic customer journey to give you that data. So it's not so much time dependent as much as you do the required flows to get the right data. Hope that answered the question. Yeah.
I think maybe one of the questions that will be helpful for the audiences could be, does this tool kind of work with other CI/CD tools or like defect management? Can I integrate this with my defect management tools where I can see everything in one place?
Yeah. So if you want to report any bug, right? So we already do have integrations with CI/CD as well as bug tracking tools like Jira, Trello, Slack, and so on. Not yet in the performance module, it is not yet live, but this is definitely something we can easily bring about for performance as well.
All right, I think that's mostly it. I don't see any more questions coming in. Yeah. I think we've answered most of the questions, Jessica. I think we're good here. All right. Thank you so much, folks. Before I end the webinar, I would like to thank Jessica for sharing your wisdom in this whole field of app performance experience testing, and the way you've done a deep dive into the root cause analysis and showing us how this performance testing can be done and assist us with our root cause analysis. So thank you. And also, we want to thank each one of our participants for joining us for this webinar. We're sure some of the ideas, some of the insights that were shared by Jessica may have sparked a few ideas to think through. My recommendation would be to mull over these ideas, talk to your teams, talk to your managers, reach out to us if you want to discuss something further, and keep the conversation going. Also, feel free to reach out to us at any time. You can write to us on email, info@pcloudy.com, or you can go out to our website, www.pcloudy.com, and use the chat option. and somebody will be right with you. And or you could even message us directly on LinkedIn. Our handles are available on our websites as well, so you can reach out to us on LinkedIn, reach out to Jessica on LinkedIn as well. And yeah, so thank you so much. Thank you for being a patient audience and also an engaging one with all those questions. And happy testing.
Thank you.